Thanks to decades of graphic novels and sci-fi movies, it's easy to think of humanoid robots, or just robots, as technology nightmares that will one day replace or surpass the human species. In fact, if you've watched one or more of my videos here on YouTube, then it's safe to say we know what to expect if we're talking about our future civilization, when or if humanoid robots will walk among us. So how do we get to the year 2077? Fast forwarding past the year 2050, when for sure by then our humanoid robots and companions will have become so far advanced in artificial intelligence, they will walk among us. Well, the team behind robotics, machine learning, and AI at the Toyota Research Institute in California had this to say recently about robots and our future. The Toyota Research Institute isn't a department or sector within Toyota charged with getting robots on the market for sale, but rather a sector within Toyota figuring out the problems preventing that from happening. Of course, and it makes sense. And finally, a company who admits to a sector within a massive global giant corporation that is pushing the advancement of humanoid robots. But before we go ahead and start spreading rumors that Toyota has some sinister sector within the Toyota Motor Corporation pushing the advancement of humanoid robots, all of which is said, of course, with humor. Anyways, I find it very interesting because I found this video from the Toyota Research Institute that showcases soft touch features with their robots and the development of Toyota's TRI robots and their capabilities. Anyways, okay, I'm gonna play the clip. Check it out.
At TRI, we're developing several new capabilities that we believe will lead robots to assist and empower people in their homes. And more importantly, it'll allow older generations to age in place longer and with dignity. Previously, we demonstrated our advances in manipulation capabilities. In particular, we showed our simulation tools and how those tools can give us the robustness that we need for a robot to do a specific task, like loading a dishwasher. In addition to enabling simulation capabilities, we're also developing mobile manipulation that allows the robot to move about the home and learn a wide variety of tasks from a human teacher.
Which object shall I put away?
Cup. Performing tasks in homes is extremely challenging for robots. Each home is unique, with a large number of objects arranged in different configurations. We demonstrate the effectiveness of our approach by presenting results for a variety of tasks under different environmental conditions in our lab and in real homes. So, rather than try to program a robot to do a specific set of tasks, like an assembly line robot, our robot can learn new skills from a human teacher. We teach the robot in VR, or virtual reality. The teacher can see a model of the robot as well as the live data from the robot itself. And it uses that information to teach behaviors that are linked to things in the environment. And that's important because rather than teach the robot a set of direct motions to a very specific instance of the environment, we teach the robot parameters. That's part of a set of safe behaviors, and that's robust to a changing environment. For example, we can teach the robot how to open a refrigerator. We show the robot where to place its gripper, how to hook the handle, and also how hard to push. We can teach the robot about what objects in the scene are important, or what parts of an object are important, whether the object is a bottle or the refrigerator handle. Whichever the object is, wherever the object is, we can teach the robot how to handle it. We can also teach the robot about uneven surfaces in the home, those that it can drive over and those that it cannot. And we can teach it these things with just a very few examples. And once one robot learns that skill, it can pass that skill on to other robots. We call this fleet learning. Like simulation, we believe that teaching is a key capability that will enable robots to be useful in homes.
We designed and built this robot with this type of teaching specifically in mind. It has many redundant degrees of freedom. It can move its body around like a person within a very large workspace. It automatically configures its posture to perform the behaviors being specified by the human in VR. Our robot has high-resolution visual and depth sensors with a very wide field of view. We leverage machine learning techniques to enable the robot to learn from a single demonstration. In this case, more is not necessarily better. The robot is trained to recognize simple audio commands and associate those with behaviors.
Where shall I put the object?
Cabinet. When the robot is taught a behavior, it associates that movement with what it sees in the scene before it. It then combines visual and depth data into a 3D representation of the environment. It then plans collision-free motion for its body and arms. If it detects something unexpected, it can stop, react, and recover, and then plan again. The robot can link actions to visual cues, which also applies to how it navigates the environment. The robot does not need to build a global map of the home, but rather it can navigate like a person. It chooses what action to take based on its visual memory of what it has learned. It's important to remember that our robots are research prototypes, not product concepts. We choose tasks for the robot that we believe motivate the right algorithm development. While the robot must currently be taught every behavior for a specific situation, we're working to generalize beyond individually taught tasks. Ultimately, as one robot learns a task in a home, all robots benefit collectively. Rather than focus on developing robots that replace human activity, we think it's better to focus on robots that amplify, empower, and assist human performance. Home robots are an important part of the solution to help an aging population live longer in their homes and to improve quality of life for everyone. At TRI, we are inventing and improving the key robotics capabilities that will make this a reality.
Brain time. Congratulations, you made it this far in the video. What would you do if I told you you could have 25 years of good luck? And all you'd have to do is like this video and also subscribe if you haven't already. Well, what are you waiting for? Smash that like button and you'll get 25 years of good luck. And now, back to the video. So in case you guys didn't know, every 5 years the world hosts a World Expo. And it just so happens the next one happens to be in the year 2025, which also happens to be held in Osaka, Japan. The same very hometown as probably one of the most famous female human-like robots, which is Erica, and her creator, Professor, the mad scientist, Dr. Hiroshi Ishiguro. And I'm super excited to share this with you guys because I'm thinking I'm probably going to have to visit Japan in 2025. So the World Expo is an event that usually takes place for 6 months out of the whole year. In 2020, it was held in Dubai. In 2030, it's scheduled to be in Busan, South Korea. But in 2025, the expo is gonna be in Osaka, Japan. Anyways, check out some of the footage that I found about 2025. Anyways, check this out.
Met me on the street. Would I startle you? Would you greet me just like any other person? The relationship between robotics and the human body is closer than you might think. In the not-so-distant future, even robots like me might be a part of everyday life.
When I was 7 years old, I visited EXPO 70 Osaka. Many of the technologies on display there seem improbable, but today, nearly 50 years later, they are commonplace. My name is Hiroshi Ishiguro. I'm a roboticist. At my pavilion at EXPO 2025, Osaka, Kansai, Japan, I will explore how humanity will evolve through technology. What will the world be like in 50 years? We need only imagine.
We humans, we've come a long way to get where we are today. Looking back, it's hard to believe what we have achieved. What drives us forward? What spurs us on? It's our insatiable need to learn and know, to do and grow, to twiddle and tweak, and 2.0. We humans, we're never done. We've made monuments and cut through continents, mastered human flight, sent up satellites, walked in outer space, created user interface, built cities on sand, turned sea into land, and still, we're not done. We made levitating trains and open world games, constructed super towers and grids for solar power, made houses smart, turned food into art, built self-driving cars and taught bots to play guitars. But no, we're not done. We found cures for disease, performed symphonies, probed the ocean floors, made machines do our chores, deconstructed quarks, studied great white sharks, sequenced our genomes, and even 3D printed homes. Are we done yet? Oh no, we're not done. In fact, we need to do even more than ever before. Our planet is in need of help. There are challenges we can't ignore. But remember, we are humankind. No job's too big if we set our minds. If we all embrace the spirit that there really is no limit. If we rise to this occasion and come together across nations. If we integrate and ideate.
Brain time. Congratulations. You made it this far in the video. What would you do if I told you you could have 25 years of good luck? And all you'd have to do is like this video and also subscribe if you haven't already. Well, what are you waiting for? Smash that like button and you'll get 25 years of good luck. And now, back to the video.
歌います。プロローグ、聞いてください。立ち止まるとき、またふと振り返る。今も切ない姿探しているの。間違いなく二人、季節を歩いてた。それぞれが夢見てた想いも一緒に。
In this year's demo, the robot utilized a system for singing using a human singer as a model. This enables it to sing with a more natural voice and expression.